In the previous question that we saw, data for intersection of only two sets was also given and only G and H were unknown. In this video, we will calculate the maximum and the minimum value of set containing all three elements when even less data is given. We only have value of three sets and nothing else. Let's start with an example. In this question, there are three sets A, B and C. Now, there are 70 elements in A, 80 in B and 90 in C, and there is a total of 100 elements. Central region is Z. So, let's calculate Z minimum. If A plus B plus C minus twice of the total elements is greater than 0, then minimum value of Z will be A plus B plus C minus twice the total. Looking for this case, A plus B plus C minus twice of total will be 70 plus 80 plus 90 minus 2 into 100, which gives us 240 minus 200, which is equal to 40. Clearly, this 40 is greater than 0. Hence, minimum value of Z in this case will be 40. We just have to calculate A plus B plus C and then subtract twice the total value. Value comes out greater than 0, then it will be equal to the minimum value of the central region. The other case, when A plus B plus C minus twice of total comes out smaller than 0, then minimum value of Z will be equal to 0 itself. This approach can be extended a little bit to calculate the values of Z minimum in case of 4 set Venn diagram and 5 set Venn diagram as well. For 4 set Venn diagram, you have to take the total of the 4 sets given and then subtract thrice of the total value. Similarly, for 5 set Venn diagram, you have to take the total of all the 5 sets given and then subtract 4 times the total value. Now, let's calculate Z maximum. Z maximum is definitely smaller or equal to the minimum among A, B and C. The approach is, we take the set which is smallest among all. Then we look at the remaining two sets. We take the difference of the respective values from the minimum value and we add all the three values. That is minimum value plus remaining values for the other two sets. Now, if this addition is greater than or equal to the total or say universal set, then Z maximum will be equal to the minimum of the three set. That is minimum of A, B or C. In this case, minimum of all the three sets is set A, whose value is 70. Now, we have to take the difference of the respective values from this minimum value. That is, for B, the remaining value will be 80 minus 70, which is 10. And for C, remaining value is 90 minus 70, which gives us 20. So, minimum plus remaining value in B plus remaining value in C gives us 70 plus 20 plus 10, which in turn gives us 100 as the answer and which is equal to the total value of the universal set. Hence, Z maximum in this case will be equal to set A, that is 70. The other case can be when this addition is not equal to the total value. Then in that case, we have to make some adjustments to overcome the deficiency of the elements. Let's apply this approach to the next question. 90 opted for marketing, 80 for finance and 100 for HR. Now we have to calculate the minimum and the maximum number of students who opted for all the three streams. Venn diagram will be like this. Now for minimum value of Z, we take A plus B plus C and then subtract twice of the total value given. So A plus B plus C minus twice of total is 90 plus 80 plus 100 minus 400. That is 270 minus 400 gives us minus 130. This value is clearly less than 0. So Z minimum in this case will be 0. For Z maximum, we have seen that its value should be less than or equal to the minimum value of the set among the three. Here, minimum is for finance, that is 80. So, Z maximum has to be equal to or less than 80. Now, we take the differences for the other two sets and add them to the minimum value. So, for marketing, difference will be 90 minus 80, that is 10, and for HR it will be 20. Now minimum plus remaining in marketing plus remaining in HR, that is 80 plus 20 plus 10, which gives us 110. This 110 is clearly less than the total value, that is 200. As I mentioned in the previous example, we have to make some adjustment to overcome this deficiency of elements. This adjustment is nothing but equal to deficit value divided by 2. Here deficit value is 200 minus 110, that is 90. So adjustment will be 90 divided by 2, that is 45. Now, for the maximum value of Z, we have to subtract this adjustment from the minimum value of the set that we had earlier taken. So, Z maximum in this case will be 80 minus 45, which gives us 35 as the final answer. There are two limitations to this approach. First, it is specifically for the questions where number of elements are fixed and there is at least one person present in one of the three sets. That means H is 0. It cannot be applied when the number of elements are not fixed. The other limitation is that it cannot be used when extra information is provided in the question, like in this question. The highlighted part is the extra information that I am talking about. Thank you for watching.